This is lesson 9-5, completing the square. The idea behind completing the square is so that we can make an equation have one side be a perfect square trinomial, in other words, a perfect square, so that we can then solve by using square roots. To find a value for the constant c that makes a perfect square trinomial, we first need to identify our b term, then take that b term and divide by 2, followed by squaring your result. Let's take a look at an example. Find a value of c that would make x squared minus 16x plus c into a perfect square trinomial. If you'd like, pause the video at this point to give yourself a chance to try it on your own. My b term in this particular trinomial is negative 16. I first want to divide negative 16 by 2, and I get negative 8. Then I square negative 8. Notice I'm keeping it in parentheses because on some calculators, if you don't put parentheses, it will make it a negative. When you square negative 8, you get a positive 64. Therefore, your c value is equal to 64. Let's discuss solving a quadratic equation by the completing the square method. I'll do an example to the right as my steps come up to the left. First, I need to get my equation where the constant is on the other side of the equation from the a term and the b term. In my example to the right, I'm going to then subtract 13 from both sides. This gives me x squared minus 14x equals negative 13. Next, I want to make the left side, my x squared plus bx side, into a perfect square trinomial. We're going to follow the same procedure that we did on the last slide. My b term in this case is negative 14. When I half negative 14, or divide by 2, I get negative 7. When I square it, I get 49. So I'm going to add 49 to the left side. That's a minus 14. Again, I'm going to add 49 to the left side because that will give me my perfect square trinomial. But whatever I do to one side, I must do to the other. So on the side with negative 13, I must add 49. Next, make your trinomial into a perfect square. This basically means to factor the trinomial. When I factor the left side, I end up with x minus 7 times x minus 7. Or I can rewrite it as x minus 7 quantity squared. If you complete the square correctly, you will always end up with a perfect square binomial. On the right side, I'm going to simplify negative 13 plus 49, which gives me a positive 36. Now, I'll find square roots on each side and simplify. So I'm going to take the square root of both sides of the equation. I'm left with x minus 7 equals plus or minus 6. Now, I do need to simplify to get my two solutions. So, x minus 7 equals 6, and x minus 7 equals negative 6. This is similar to my zero products property, except we're going to have 6 and negative 6. So now, and I even might want to split it up like such. So now, I'll add 7 on both sides, and I get, on the left, x equal to 13. There's one of my solutions. On the other side, I'll do the same thing and add 7. And I end up with x equals 1. Here's an example for you to try on your own. Find the solutions to x squared plus 6x plus 5 equals 0 by completing the square. Pause the video at this point to give yourself a chance to try it on your own. So the first thing I want to do is subtract 5 from both sides. That puts my constant on the opposite side of the equation. So now I have x squared plus 6x equals negative 5. I'll now do the completing the square procedure. My b term in this case is 6. Half of 6 is 3, and squaring 3 gives me 9. So now I have x squared plus 6x plus 9 equals negative 5 plus 9. When I factor x squared plus 6x plus 9, I end up with the quantity x plus 3 squared. Simplifying the right side, negative 5 plus 9 is a positive 4. Now, I'll square root both sides. And I'm left with x plus 3 equals plus or minus 2. Now, I can write it as two separate solutions. X plus 3 equals 2, and x plus 3 equals negative 2. Subtracting 3 from both sides on the left gives me x equal to negative 1. Subtracting 3 on the right side gives me x equal to negative 5. The vertex form of any quadratic function is just another way to write it. The nice part about the vertex form is that we can clearly display the vertex of any parabola when we change it to this form. Vertex form of a parabola is y equals the quantity x minus h squared plus k. H, positive h, and k are your vertex of your parabola. Those are the coordinates of your vertex of the parabola. We can easily get into vertex form by doing the completing the square procedure. Let's show how to find the vertex by the completing the square procedure. Once again, I'll have my example on the right as I go through the steps on the left. The first thing I want to do is get at the function into y plus c equals x squared plus bx form. In other words, I need to take my constant term and move it over to the side with y. So on my example to the right, I'm going to subtract 8 from both sides. That gives me y minus 8 equals x squared plus 6x. Next, on the right side, complete the square to get the perfect square trinomial. My b term in this case is 6. 6 divided by 2 is 3, and 3 squared is 9. So I'm going to add 9 to both this side and the side with y minus 8. This gives me y plus 1 equal to x squared plus 6x plus 9. Now, when I complete the square to get the perfect square trinomial, now I can write it as a perfect square. When I factor x squared plus 6x plus 9, I end up with x plus 3 quantity squared. Now, to get it into vertex form and to name the vertex, I need to get y by itself. So I'm going to subtract 1 from both sides. Vertex form of this parabola is now y equals the quantity x plus 3 squared minus 1. Keep in mind that the vertex form was y equals x, the quantity x minus h squared plus k. So my vertex here is going to be the opposite of what I see in parentheses, which is negative 3, and exactly what I see on the outside for k, negative 1. My vertex here is negative 3, negative 1. I can graph it to make sure that I'm correct. Here's an example for you to try. Find the vertex of y equals x squared plus 4x minus 16 by completing the square. Pause the video at this point to give yourself a chance to do the example on your own. So the first thing I want to do is add 16, the constant, to both sides. That gives me y plus 16 equals x squared plus 4x. Now I'll make a perfect square trinomial by completing the square on the right side of the equation. Half of 4 is 2, and squaring 2 gives me 4. So I'm going to add 4 to both sides. That'll give me y plus 20 equals x squared plus 4x plus 4. Now I'm going to rewrite it as a perfect square. So y plus 20 equals x plus 2 quantity squared. Now subtracting 20 from both sides will put me into vertex form. Vertex form of this parabola is y equals the quantity x plus 2 squared minus 20. My vertex in this case will be the opposite of 2, which is negative 2, and exactly what's written on the end, negative 20. If you're having any issues with this particular lesson, please make sure you consult your teacher in class.